Okay, we're going to talk now about inverse normal problems. Effectively, we're undoing the problem that we've been doing. So, up until now, you've been told a mean, you've been told a standard deviation, and you've been asked to work out a probability. In fact, you've actually been asked to work out an area, which translates into a probability. Inverse normal problems, we get given the area / the probability, and we get asked to work out the limits. Okay, so we're undoing the problem. I'm going to start with a question from the text, page 366, and I'm going to start with question 8. The heights of passengers on a particular airline have been found to be normally distributed with a mean of 175 and a standard deviation of 4. If I were doing this question, I would be drawing a picture, and I would put in that bit of information on the picture. 175 and standard deviation 4. The airline wants to install seats so that 98% of passengers are short enough to fit the seats without their knees touching the seat in front. What height of passenger should the seats be designed for? So passengers have a mean height of 175 with a standard deviation of 4. We want to find %, that area, and we want to find that limit, that one, and that one. The two values. So I'm sitting in front of the screen. Now, give me a wave if you have a green calculator. Okay. For the green calculators, it's a slightly different process. If you have a green calculator, you need to put in the area to the left. Okay? So you always put in the area to the left. If you have a later model, the dark blue calculator, you have a button on there that says middle, and you can just put in the 98%. So I'm illustrating on the green calculator. Okay, so menu, stats mode, distributions, normal distribution. Instead of where we used to go, NCD, we're now going to go to inverse. Actually, I lie. I'm actually illustrating on the later model, the dark blue version, because I've actually got the option of putting in, if it's a centre problem, a left problem, or a right problem. What that refers to is this would be a left problem. Left, as opposed to a right problem, as opposed to a centre problem, which is the one that we're doing now. So we're doing a centre problem, so the first thing to do is click centre or central. Area is 98. I'm not sure if it'll let you put 98. I think you have to put in 0.98. But try and find out. Standard deviation is 4. And the mean is 78, I believe. 78? Oh, thank you. 175. And execute. So those are my two lower and upper values. So I should design the seat to fit a person with minimum height 165.7 centimetres and maximum value of 184.3 centimetres. For those with the green calculator, instead of putting in 98.98, you have to put in actually 0.01. You have to put in the area to the left. Now, 98 leaves 2% left, 1% is there, and 1% is there. So hence, if you put in the area, the green calculator is set, it's always just set on left. You can't change whether it's centre or right. It's always set on left. So you have to put in 0.01 to get that value. And then you have to do the problem again, and you have to put in what to get this value? 0.99. Okay, because it's always set with area to the left. You can't change it. Okay, I'll do one more problem. Or is that enough? Question 9. Calculators last on average 4 years before developing a non-accidental defect. This time is normally distributed with a standard deviation of 10 months. If the retailer is only willing to replace 2% of calculators under guarantee, what length of guarantee to the nearest month should be offered? How many months? We need to convert the years into months, don't we? How many months in 4 years?
48.
Thank you. So again, the first thing I always do is a little picture. The mean number of months that the calculator lasts is 48 months. The standard deviation is 10 months. If the retailer is only willing to replace 2% of calculators, what length of guarantee should be offered? So the question, if you can draw the picture correctly, you should be able to get the answer correct. So the question really is that the 2% they're referring to? Remember, it's only willing to replace 2% of calculators. Or is it this they're talking about? Why do you say the left? Because why, sorry? It's a less amount of time, isn't it? So you kind of want to guarantee for it for the least amount of time possible, and to the left is a number less than 48, less than the average. So we are looking for that value there. Okay, so once you've got that much, the problem becomes quite easy. Graphics calculator. Area is what? No. Is it a left, central, or right problem? Left problem. Area is 0.02. And this is the same for the green calculators because it's stuck on left anyway. And the standard deviation? 10, the mean? 48, wasn't it? And what's this going to tell us? 27 what? And it says, the question asks us to give our answer in the nearest month. So in there goes 27 months. So guarantee and probably in reality it'll be 2 years, wouldn't it? 24 months. You wouldn't say, I'll guarantee that for 27 months. You'll say 24 months guarantee.